Now let's extend the logic that we've learned so far a little bit. Now let's say we have to divide a largest number which is of the form 8, let's say to the power 3, right, by 7 and find out what the remainder is going to be, right? So you notice the power here, right? So instead of just 3 numbers multiplying, this is the same number whose power I have to find. Now if this is 8 to the power 3, which must be divided by 7, then actually this can be written as 8 into 8 into 8, that must be divided by 7. Now 8 leaves the remainder 1, and this set also leaves a remainder 1, and this set also leaves a remainder 1. So the product actually leaves a remainder cube, right? So this is the final answer when 8 cube is divided by 7. Now this tells me that any power of 8 when divided by 7 will give me 1 as a remainder, right? Now if I extend this further, let's say I take another case. Let's say there is this number 2 to the power 2000, right? And I got to divide this by 7 and find the remainder, right? Now when 2 to the power 2000 is being divided by 7 and I got to find the remainder, I notice that the base is 2 is smaller than the number dividing it, than divisor, right? So what do I do in cases like these? So let me say that this is the first special case where the base whose power gives me the final number that must be divided by another number by the divisor, base is much smaller than the divisor. Now up till now this had not been a problem, but if I have to find out what the remainder is going to be, now what I do is I start finding I start powering up the base. I start powering up the base until I reach a number which is close enough to 7, right? So 2 to the power 1 is 2, not close enough. 2 to the power 2 is 4, still not close enough. But 2 to the power 3, 8 is very close to 7, close to the divisor 7, right? Now how is this going to help me? Now the way this is going to help me, right, is now I am going to try and convert 2 to the power 2000 to as many 8 to the power something as possible, right? Now clearly I may not be able to convert the whole thing into 8 to the power something, but I will try my level best to convert as much of this as possible to 8 to the power something and whatever powers of 2 are left, right? Now I notice that it's 2 to the power 3, which is 8, right? And I need to convert most of this into 8 to the power something. Clearly I need to bring 3 in. I need to bring 3 in, but 2000 is not a multiple of 3. So I'll just quickly check what 2000 is in the form of a multiple of 3. Now when I divide this by 3, right, I get 3, 6, 6 and 6 and the remainder 2, right? So 2000 is 3 times 666 plus 2. So 2 to the power 2000 I am rewriting as 3 into 666 plus 2, which leads me to rewrite this as 2 cube into 666 multiplied by 2 squared, right? Now this becomes 8 to the power something. You notice this, 2 to the power 3. So what I can do is I can rewrite this as 2 cube whole to the power 666, and I'm left with a 2 squared here. Now 2 cube is 8, 8 to the power 666 into 2 squared. Now this problem, 2 to the power 2000, and this number leaving a remainder when divided by 7 is the same as this problem. So I split up 2 to the power 2000 into 2 parts. The first part is 8 to the power something and the second part is 4. Now 8 to the power 666, this remainder, when this is divided by 7, is the same as remainder 1 to the power 666, and that's what we've seen here, right? So if 8 to the power 3, it leaves a remainder 1, then 8 to the power 666 also, right, must leave a remainder plus 1, and when 4 is divided by 7, the remainder is 4. So my answer is plain and simple, 1 into 4, which is 4, right? So straightforward, 2 to the power 2000 is now split into 8 to the power something and the rest of it. Why? Because 8, it passes very close to 7. My remainder is 1. So I just strip this down to the bare minimum, 1 to the power 666. That's my remainder of this largest number. And when 4 is divided by 7, the remainder is 4. My answer is 1 times 4, right? Let's take another example. Now this time what I'm going to do is I'm going to multiply, I'm going to do this. So in this problem I'm going to take 5555 to the power 2222, right? And I'm going to take 2222 to the power 5555, right? Now I have to check whether this sum is in its entirety divisible by 7 or what is the remainder when this whole thing is divided by 7, right? So let's pick up the first part. So let's first thing divide 5555 by 7 and see what the remainder is. So 5555 when divided by 7 gives me 7 7 the 49, 65 7 9 the 63, 25 7 3 the 21. It leaves a remainder 4, right? So the equivalent of remainder when 5555 to the power 2222 is divided by 7 is equivalent of 4 to the power 2222 when divided by 7, right? So this is what this reduces to. Now let's do it. Let's do the same thing with 2222. Let's divide this by 7 times 3, 21, 12, 7 1 the 7, 52, 7 7 the 49, and remainder 3. So 222 when it divides by 7 leaves a remainder 3. So 2222 to the power 5555, sorry, to the power 5555 when divided by 7 should leave a remainder 3 to the power 5555, right? Now let's move on. Now 4, it passes, I mean 4 is, 4 to the power is going to be a very large number for me. So I'm again going to try and find a power of 4 which passes close to 7 or close to a multiple of 7, right? So that I can write it in the form 7n plus something. So let's look at the powers of 4. So 4 to the power 1 is 4, still far away from 7. 4 squared is 16, right? So this is 14 plus 2. So if I'm going to reduce 4 squared, I'm going to at best get the power 2, right? Then 2 I can subsequently convert it into 8. So this works for me. So to convert this into 4 squared, what do? I make it 4 squared to the power 1111, right? So this is going to make my life easier. Then let's look at 3 to the power 5555. So 3 3 the 9, right? So 3 squared directly, it takes me close to, it takes me two numbers away from 7. But what happens when I do 3 cube? When I do 3 cube, then 3 cube is 27. Now 27 is 1 unit away from 28. Right? So remainder from 3 cube is minus 1. So this is good enough, right? Actually, what I could also do here is 4 cube is 64, right? So which is 1 unit away from 63. So I could have done that also, but let's continue with this thought. So we'll convert 3 to the power 5555 into 3 to the power 3 form, right? Just like we did in the previous example. So When I divide 5555 by 3, I get the remainder. This is 1, 25, 8. So this is 1, then 25, 8 the 24, 15, 5 the 15, 1 the 3, remainder is 2, right? So this becomes 3 to the power 3, right, and some power, right, actually 1851 multiplied by 3 squared, right? So let me just separate out the mess.